I did some work offline to help with persisting a navigation mesh. So we, let me just recap over here. So we have space. A space has entities. Entities have components. And this is loaded initially through serialization. So we get this data through serialize, which gives you some JSON object of everything in the scene. But in order for enemies, agents, to travel to you and around these objects, we need a navigation mesh. And the navigation mesh is created through a babylonjs plugin. It's called Recast. So this plugin has methods to create a nav mesh, and it takes a list of meshes. And now you have a nav mesh, which is just inside this plugin. And with the plugin, you can create crowd agents, and then you can say move over here, move over there, compute path, and it will move along this navigation mesh. Then this is somewhat expensive to compute in the client when your mesh is big or complicated. So they provide a method to create this within the web worker, but I found that that doesn't work well in the Oculus Quest, and we don't want to. So for this version, I'll just not use the web worker, but also I don't want every client to have to compute it, so I would like to cache it. So in order to cache it, we can, if we've already created it, we can extract the data out of it. So we can say plugin, get the data, something like that, and then we'll save it to the database. Then in the future, when clients load the page, they can check the cache. Do you get a cache hit? If yes, then load the plugin, load data from the binary. And if you don't have the cache, then go through this part, create it, and then bake it, save it to the database. So let me just go through the pieces that were necessary for this, starting from the backend. So if we look at the migrations, there is a new table called nav meshes that currently only holds a nav mesh. Maybe I could make this a bit more generic to hold any kind of binary data, but right now nav mesh is the only thing I need. So it has an ID that we're not using, and it's related to a space. And there's a unique index on the space ID, so you can only have one record, one nav mesh record per space. And then it has this binary field, which I think would be a Postgres blob type of thing, hold any kind of binary data. So that is the table. Then we go up one level to the schema. So we have a nav mesh schema. And here's your typical module. It uses the schema, and this will allow us to use this module with the repo in order to make requests. And I don't think we actually make use of this change set because we're going to set the data directly into the object. It's very simple. It's just got binary data and a space ID. So here it just says we're using the nav meshes table. Here's a change set that we don't really use, but just following that pattern. And then we go to the context for spaces. At the end of spaces, I created two, maybe three mechanisms. So you can set the data, and this does an upsert. So you just pass in that object. So here's the binary data. You just say space ID, and here's binary data. And essentially we create this struct for the insert. But if there's a conflict on space ID, because maybe the record already exists, then you're going to set the data. You override the data. So this is an upsert for set the nav mesh. And then getting the nav mesh, having that struct here allows us to do from this object, select the data. So we only want the data where the space ID matches, and then we get back that one record, which can be nil or the binary data. Finally, we have this is just in case we, um, if we want to send um, no data, like an empty string from the front end, which I've actually prevented from doing this. Like, we don't really need this. It will set that to nil anyway. Maybe we don't need this. Let's probably can get rid of this. Then I have one that's just for completeness, delete that nav mesh, which we want. If we're clearing the cache, we just remove that record entirely. And so that's removed. And we'll do that when anybody's editing the scene, changing something, then we want to clear the cache. So that's the context. Then what calls the context? It will be the controller. So we have the space controller, which we've been using to load up the space. Here's our show. And further down, we have the three different kind of straight through mapping. These are calling those contexts almost vanilla. The only difference is that you're parsing the parameters through the connection. So you have in the delete, you're given the space ID and you delete that space mess. In the save, you give them the space ID, and then you use this plug con to read the post body, which will give you back the binary data, and then you just call spaces set save mesh with that binary data. And finally, you can get the data out of the database, which will either have no record here, so it will return nil, in which case you just give no content, or you find a record and this will return a 200 code. So that's the space controller. And what calls the space controller? It will be the space manager as it's loading up. Scene manager. As we're constructing the scene, we do create scene, right? Whoops. Create the scene. This is where we create the scene for the first time. And then we're loading up all the entities. So the entities are in this object coming from the serialized space. So when this whole scene manager is initialized in its constructor, I believe we're past the orchestrator, and the orchestrator has the serialized space, and then the entities are on the serialized space. So all of these things. I think the serialized space only has two objects, settings and entities. Maybe we want to create a third one for monsters, or maybe monsters are entities. I'm not sure. What else? Yes, so we're in create scene, and we have that list of entities. So we go parse initial scene. Here, for every JSON object that is an entity, we actually go and create that mesh in the babylonjs JavaScript function call, creating boxes or primitives, spheres, what have you, and you get a list of meshes that you've created. So you pass this list of meshes to nav manager, which is a new thing that we've created. So nav manager is instantiated a little bit before this, and then that will load the plugin, and this will make use of creating the nav manager. So we look at this, load or make the nav mesh. Load or make nav mesh takes that list of meshes, and then it checks a couple of things. This is that cache check that I told you about. So first, we'll say fetch cached binary data. So this makes a call to the controller, to the database, saying, hey, do we have binary data for pre-calculated nav mesh that we've done in the past? If we don't, then take those meshes and ask the plugin to create a new navigation mesh. And with that, we extract the data and we send it back down to Space Controller and say, save this in the database. So that's called baking that nav mesh. So we'll have it in the future. And then if we do have it, we'll just load that binary into the plugin. So the second time we come down here, this should have something and we'll just be loading here. So we don't have to do this time and time again. Finally, so we can see something on the front end, we create the debug mesh, which creates this red semi-transparent layer on top of it. So we know that the nav mesh was correctly created. So if you look through this fetch binary data, I had to manually construct the GET request. So CSRF token is not required for the GET request. Here we're going to fetch the new endpoint that I created. Oh yes, I forgot to mention I added a router. So there's a new router on right after space ID, which is concerning all the nav mesh stuff. So this is the GET. We want to get the binary data for your nav mesh. You want to save a new nav mesh or the new binary data, or you want to just delete it. And let's see what else. So this is the path here, and going back to nav manager, it will get the return response. So if it's 200, it will take that blob of data, convert it to an array buffer, and then create a new view for that array buffer. So this is just binary data, but this formats it or interprets it as 8-bit pieces of numbers, which is what that plugin requires. So here we'll have that data, otherwise we'll have nothing. Then if we have nothing, create that nav mesh, and this is just taking the meshes array, and we're doing some protection here because in the first case we're not the very time you open a space, the very first time you open up a space, it's not going to have anything, no cache, but also no meshes. So here it's just a protection to say, if you've given me no meshes, let's just return early. But if there's at least one mesh, then I will create a navigation mesh out of it, and then I will set a flag to be true, because there's a subsequent step here, which is assuming that you created the nav mesh, and then this will call bake. Maybe I could just put this into a, no, I think that's fine. Create nav mesh, load binary plugin. Yeah, because we need it over here too. Okay, so at this step we set that variable to nav mesh created. Then we go to bake it. If nav mesh was not created, then return. Don't bake it. Otherwise, you extract the data from the plugin, get nav mesh data, and then you take that blob, or you make that data into a blob, say new blob with data buffer. So this takes the unsigned int 8 array, creates a blob, and then we pass that blob to our custom XML request. So we say this time it's a post. Being a post, we have to pass in the SRF token, which we extracted from some metadata HTML tag that was in the page already. Say that it's a multi-form request, and then post it. So that's baking the data. And finally, if we did have it, then we just straight calling load data from the binary. So this is taking the binary data and loading it into the plugin. And we also have to set this thing true as well, because we created a nav mesh. Therefore, in the create debug mesh, where we're just extracting the debug mesh out of the plugin, so they provided a method for this, we won't do this if the nav mesh isn't created from us creating it from a new, or us creating it from the binary data. So this covers that case, and then it will create that. So if we just want to see this in action, we load up the server, then we can go to localhost. I had one open. And let's start with a new space. So this has nothing. Open up the inspector just so you can see when we enter it, we don't get any errors or anything. There's just nothing. Then we can create a grid. Now, there's no nav mesh now because that parsing, it only happens on pre-existing data. So I've currently, if you're editing it, I don't want it to be creating a nav mesh in between all of your edits. Instead, I would just clear the scene so when you refreshed, you would get the nav mesh. So the calculation happens one time on the first refresh. So here you can see we've created a nav mesh here, building debug mesh. And it's because it found it. And subsequently, when you reload it, it won't go and create it, it just loads it. So you don't see a creating nav mesh output here, it's just loading it from cache. But if we go and delete that, so if we could say, let's just delete all nav meshes. When we come back here, it will once again create it from the cache. So it's creating the nav mesh here. And that's it. So that's just allowing every client to efficiently grab the existing nav mesh that was pre-calculated by some client and save for everyone, or creating it fresh. There might be a race condition if multiple clients load at the same time, but it will be just the last person will win out. So I think that should be fine. In most cases, there's somewhat of a few second delay when people are signing on anyway. And if you're the editor of the page, your solo editor, just refresh the page once and then you'll cache it for everybody. And that's it.